Good morning, everybody, to this Thursday where I'm just waiting for my drawing program to open up and we will get started. It's loading, it's coming, it's happening. Now, I looked at the schedule, and for the next couple of sessions, our session isn't very full, to be honest. Our pace is slowing down because I matched what usually happens in the face-to-face version. And usually there's a lot of catch-up time and time for questions and just making sure people are up to speed with everything and have time for their questions. So I followed the same kind of schedule. And as a result, we won't necessarily have full lectures every time for the upcoming topics. They're not terribly big topics, and I would like more of a discussion than a lecture. All right, so let's paint a picture here for chapter, what was it? I just looked at it. What was the chapter number here? Not that it really matters. 12. 12. So now, throughout history, whoopsie, go back. We have here topic 12. People started using numbers based on their needs. And the very beginning, they needed to count maybe the days or the seasons or something, and there could be one thing, two things, three, depending on what they wanted. And we had these sometimes called counting numbers. Counting numbers. Then eventually they realized that, oh, zero is a number like any other number. The concept of having nothing is just as important as having something. Maybe a little philosophical, but still, they extended their numbers to what we now call the natural numbers. Sometimes this n with a double line is given as a symbol. Then they realized, well, okay, these numbers, apart from zero, represent the concept of me having something. Maybe I have some chickens on my farm or whatever. That's great. But I could also owe something to someone else. Maybe then my neighbor did me a favor, and in exchange, I promise him a couple of chickens. I kind of have to represent that debt as well. So they extended the numbers to the same. I'm just copying these down that were there previously, that continue forever. And they introduced these negative numbers that they could have represented it with any kind of symbols, but they represented it in a way that sort of mirrors the natural numbers. And this collection of numbers are called the integers. And sometimes a symbol is used to represent that, but we don't need to really care about that. Now we have the positive integers, which is why we don't really use the word counting numbers anymore. We just say positive integers or negative integers to refer to a selection of these numbers. All right. So now what we have is our so-called number line, where at this stage they didn't necessarily think that there could be anything in between. They just wanted to count their chickens, and I never have a fraction of a chicken, right? So fractions and things like that came a little bit later based on the need. So if we just stop here and wait for our discussion on fractions a little bit later, we have our number line that is introduced in elementary school at a very early stage. So now I want to spend some time in this very basic place where my explanations for how to perform basic arithmetic, addition, subtraction, using this number line is one of the early things that I'll be introducing in elementary school. So we want to explore the so-called number line model for addition and subtraction of integers. There are other ways to do it. This is one framework, one story, one method to help early students put these numbers together in a way that gives them the answer and kind of makes sense as well. Using the number line is one such method, one such model to help them visualize and come up with a systematic way to do things that we take for granted, right? The first time they have to do 2 plus 3, they have to think about that. That is a novel concept that requires some thought. Yes, repeat that thousands and thousands of times and you stop thinking about it. But those early stages, I need to have an appreciation for the difficulty that they could experience. And if I just go with the approach of 2 plus 3 is 5, why don't you know it's 5? What's wrong with you? Whether I say those words or sort of imply them with my reactions, that gives a very negative feeling about numbers, and then they take that with them forever. So I need to have an appreciation. Well, at this very basic first step, how can I effectively help them figure out how to add and subtract integers? Now, sometimes initially, maybe you would just spend time with the positive integers, but technically these are all the same, just points on the number line representing different things. So positive, negative integers, it doesn't actually matter. All right, so we'll just do it by way of an example. Now I just need to check if I maybe have specific examples I already want to do. We might as well look at exercise 12.1. I think it covers all the combinations of addition, subtraction, positive integers, negative integers, all kinds of things. So I want to have a story. So this will be exercise 12.1. I want to sort of have a story to help them figure out, well, if I have a calculation with integers, how do I use this number line to help me find the answer? That is what we want to do. I want to have this helper number line instead of just sort of letting these numbers float around in my head and hope that I have a good sense of these things. No, I have to develop that number sense. Okay. So here we are thinking extremely basic. Grade 1, if not earlier. And I need to demonstrate on the number line, how do I figure out what 3 plus 2 is. So the answer is not a challenge for us. It's explaining it by way of this number line. So it'll happen in a few steps. Each of these things tell me something. They provide instructions for how to use the number line to find the answer. But I have to just put some numbers on there. Now, initially, uh, kids are very attached to starting at 0. So let's just do that. It doesn't matter. As long as I have all the numbers that I need to have visible on the number line, of course, I can have many more. I just need to have the important ones. So I'm just going to copy this over here. Each of these things will tell me something. And the first one is going to tell me where I need to stand on the number line. I need to stand right there at that first number's position on the number line. Then I need to look a certain direction. The number line has two directions. The addition here, this tells me that I'm looking to add. Now, intuitively, adding means I want to make it bigger, ideally. So I'm going to look in the bigger direction of the number line. I'm just going to give this guy a big bobblehead. Woo! So that I can see the way he looks, and I'll emphasize that with his vision lines. I'm looking to the bigger side because adding wants to, in a very, very basic sense, make more. I want to add, I want to have more. So I'm looking, I'm ready to make more. Then I want to step in the direction according to the second number, and that number says take 2 steps forward. So I'm going to get to my end destination and say the answer is 5. And yes, we might look at this and say, why are you making such a big deal of something that is so simple? But we need to have perspective that at the right age, this is completely brand new information and it's not simple at all. And I should have an appreciation for that and never make it sound as if it's easier than the student perceives it. It's not easy. Anything you see for the first time is potentially difficult. So with the number line, we want to give a systematic approach to finding this answer. When they're just building that early stages of number sense and seeing how these things work. This is one approach. It's not the only approach. The number line is one approach. I've done it. It works. They take to the number line fairly well. So in the basic one, we have 2 positive integers, and adding is, of course, easier. All right. So again, I'm not trying to stretch this out. I want to just provide enough detail. We'll still end fairly early. Interrupt me at any stage if you have questions or thoughts or insights, maybe experience with this, all kinds of things. So we just want to mix up addition and subtraction and positive and negative integers. But it's always going to be this look, this stand, look, and step, or whatever you want to call it. I need to move my, can I not move my page? Why not? There we go. Oops, because I'm at the end of the page and I need to make a new one. That's why. Yeah, people underestimate these simple things until they're sitting in front of little Timmy, little kindergarten Timmy, and they have to explain things on an extremely basic level. Then, honestly, if you've never thought about this, it's not going to be easy to explain things. And that is going to create a lot of confusion potentially. Now, when we represent negative integers, you'll see in the book it's done like that as well. Do not confuse it with the plus sign. They sometimes put the negative a little higher. You can even put brackets around it to remind yourself that that -4 is a representation of a point on the number line, of an amount of debt, or whatever you want to call it. This is not the same in any way as that. This negative is just a convenient symbol, and it's attached to the name, the representation of that negative integer. This plus is an operation telling me what to do and how to combine these two quantities. They're completely different. And when I put them in the same line, or I don't have the brackets, people see them as the same. They're not at all the same. Not even close. Now, there's a reason we use this negative that looks the same as a minus sign, but right now it's not at all. All right. So let's make my number line. No, not, I'm used to calculus and write an X there. Just a number line. Now, later on, they'll notice that, oh, I just need to mark off the first number. Let's put it over here. It doesn't really matter that I have a 0 or not. But that first number, I want to have some stuff around it. Now I know when I represent negative integers, my little negative line here is not necessarily high enough, but in the beginning especially, to emphasize that it's different from the minus operation, the minus sign, put it a little higher, attach it to that number. It's just a name. Could have been anything. Could have been anything. It could have been squiggle 1, squiggle 2, squiggle 3. Could have been represented like that. And maybe early on it was represented in a different way until we realized some mathematical properties and a more convenient naming system. It's just a name. So I have three things here. I have two numbers and an operation in between. First number says where I should stand. Let's make bobblehead standing at that first position. Then I'm looking to add. Adding is looking, it wants to make bigger. I want to have more stuff. I want to add to my stuff. I'm ready to make bigger. Then I look at how I should step. Now, if, for example, this was just a 4, then I would take 4 steps forward. -4 is, in a sense, the opposite of 4. It stands on the opposite end of 4 when my mirror line is at 0. So I should do the opposite that I do when I have a 4, which means I need to take 4 steps backwards. And that's my answer, which we knew is the answer. So it's very important because you're welcome to write words and sentences, of course, but my diagram should very clearly illustrate the stand, the look, the step. There's a 3-step process here. What is this? Why is this here? Why is this here? Get away from me. I don't know how to get rid of it. What did I do? Why is this guy giving me the wrong pen? Am I just completely missing the point? I can draw circles. It doesn't want to do anything. Did I just miss something here? Whatever. I have my answer. We'll figure this out in a second. So you have to, with your diagram, be very clear that you're standing in the right position according to the first number, that you're looking according to addition or subtraction, and we'll get to subtraction. Addition wants to, in the most basic sense, make bigger. I'm ready. I'm looking bigger. Make it very clear, or you're going to lose marks. and then I'm stepping according to the second number. And if the second number is a negative number, that's the opposite of its positive counterpart, which means I step backwards. All right. Now, I don't know, maybe making a new page will clear things up. No, of course not. Why would it? Why is my pointer all messed up? What did I do? I did something. It's unhappy. All right, seems to be back. Let's move on to number 3. Number 3 is 3 minus 5. Now, let me emphasize here, because maybe I wasn't completely clear. We have to show, demonstrate, use this number line model when it says use the number line model. Now, I am not in grade 1. I perhaps know more shortcuts and properties for how addition and subtraction and positive and negative integers are all related to each other and can be simplified. However, at this level, I don't have that knowledge. I cannot, let me emphasize that by writing it out, so that if anyone does this, there is evidence in the video that I have said, you cannot do this. Let me write it out in big letters. You cannot say 1 plus negative 4 is 1 minus 4, which is negative 3. You will get 0, because that is not the point of the question. It is correct, but at this level, there is no sense of, oh, a positive and a negative makes a negative. There's nothing like that, nor should there be. We're building number sense. We're not building little robots that can do shortcut simplifications with no understanding. This will get you 0. You have to demonstrate the number line, stand, look, step, because that is how it is if you're using the number line model, that is how you are going to explain it. Only bad teachers give these shortcuts early. That is not how it's done. So you have been warned. Now we can move on. Now, number 3. 3 minus 5. Using the number line model. My number line model is a little downhill, but that's okay. I want to have some numbers here. Now I know secretly, and with experience, little Timmy can know that too, that the first number is really where I should mark and put some numbers around that. They are not going to know initially how many numbers do I mark off. Just as many as you have space for. 5, 6, 7, maybe an 8 there. That's my space. And if it turns out I need more, extend the line. That's totally fine. They're worried about things like that. How do I know how many numbers to mark off? Don't worry about it. You have infinite space. The numbers never stop. All right, so I stand at my first number. Now the instructions are to subtract. Now in general, subtraction wants to make less. So I'm going to look and make it very clear where I look, to the left. If your standing position isn't clear, if your looking direction isn't clear, or you're stepping, it's -1 for each of those things because they are fundamental to the number line model. So I'm ready, I'm standing, I'm looking according to what this says. So I'm sort of looking in sections. I just see the 3. I don't look at anything else coming up. That tells me where to stand. Then I'm expanding my view and I'm looking at the operation. It's a minus. So before looking any further, I'm getting ready. Well, subtraction, intuitively, I want to make less. I'm taking away, I'm subtracting. Okay, I'm ready. I'm looking to go to the lower end of the number line. Then I look at the last number and see, oh, make 5 less. Okay, so I'm going to step forward 5 steps, and where I'm at, my destination is the answer. Stand, look, step. Let's see another one. Next one, I want to have -4 minus -2. Put brackets there if it helps you. To remind you, that is a single thing representation. Yes, there are a couple of markings in that representation, but that's just an arbitrary choice. It doesn't have to be. So I will put some numbers down. I will maybe put a -7 and a -6 and a -5 and a -4, -3, -2, -1 and a 0, and maybe that's all I need. I put blinders on. I don't read ahead. I read the first number that tells me where to stand. -4 is a position on the number line. Then I look at the next bit, which is the subtraction. I'm looking to subtract. All right. I'm ready. I'm looking in the smaller direction, so to speak, of the number line, looking to take away, looking to have less. Ready. Then I look at that last number telling me how to step. Well, if it was a 2, I would step forward 2 directions. I would lose 2 things, 2 steps. Now it's -2, so I need to do the opposite, which means I step backwards, and I end up at -2, which we of course know is the answer, but little Timmy doesn't know that. Little Timmy needs to rely on the number line in order to find that answer. And over time, he'll be able to drop the number line and have that number sense to quickly do it in his head, but that's not going to happen at the beginning. He needs to slowly and systematically figure it out because this is as hard a question as he has ever gotten. So we need to have an appreciation for that. So the first number is always where I stand. Adding or subtracting tells me how to look. Larger direction of the number line, smaller direction of the number line. Then the second number, if it's a positive integer, I step forward based on how I'm looking. If it's a negative integer, I step back based on how I'm looking. Now, of course, all this is summarized in the book as well. There is a sort of a recipe, a sequence of steps, a method that one can follow that gives structure and makes it not feel overwhelming. That any combination of 2 integers, addition or subtraction, and we can follow this method and always find the answer. That is the number line model. And again, I'll make it clear so there is no confusion. If the question says use the number line model, you have to explain it and demonstrate it and illustrate it clearly enough to show exactly how that is used. It's not about finding the answer. Of course, if you find the wrong answer, then I do have to subtract something. But it's not about finding the answer. It's about using the method to get there. The answer to us is not a challenge in any way. Not a challenge in any way. And I'll emphasize again, not. I cannot use my knowledge that's beyond this level and say -4 minus -2. Oh, I know that 2 negatives make a positive. So that's the same as adding 2, and therefore that's -2. Yes, of course that's correct. But that's not the point of this question. Okay, you will get 0 for that because that's not what the question is asking. We are at a very early stage where no mathematical properties between negative integers and subtraction and all kinds of stuff happens. Once the number line is more comfortable, you can introduce these equivalencies. This left one is equivalent to the right one by exploration, by leading the student through examples and say, well, let's have a look. We can do -4 minus -2 using our number line model. We get an answer of -2. Is there another way we could do that? Well, let's just make an easier example and get rid of all these negatives. New page. Though it's not the first thing, when they're comfortable with the number line model and finding their answers, you can then introduce that next layer. Because ultimately, the goal is to not draw the number line and not have your little stick figure stand and look and step. Of course, ultimately, that's your goal, but that's not the first thing you do. Let's take an example. Let's make it super simple. Let's take 3 plus 2. Why not? Super simple. Now little Timmy might need to stand at 3. Let's mark some numbers here. 0, 1, 2, 3, 4, 5, and 6. So, okay, we're comfortable. We're getting more comfortable with the number line model. He knows to stand at the first number, look according to addition, step according to the second number, which tells him step forward 2 spots, and therefore the answer is 5. No problem. But you can then slowly over time introduce the observation or make the observation that, look, I could have gotten from 3 to 5 in a different way. I can't stand at 3. Of course, I have to start at 3. It's my first number. Let's do it over here. Instead, I'm going to subtract. So I'm going to look the other way. I have 2 options for how to look. What if I look the other way? How do I now get to 5? Now I have to step backwards, which means I need to subtract a -2 steps, and I'll still end up at 5. So when I'm traveling on the number line, because I have an option to look and to then step, I always have 2 ways of getting from the start position to the end position. There's always 2 ways. And then slowly we phase out the number line. We phase out the drawing. And we naturally come to the conclusion that, or casually speaking, 2 negatives make a positive. That's how we say it to remember. That's, of course, horribly wrong, technically speaking, because this negative, this little line here is not a minus sign in any way, or whatever. It's written like this to make this little shortcut convenient. But that doesn't happen first or second. It happens later when the student naturally doesn't draw the number line anymore, but maybe can just picture it. And that picture starts to become less and less clear, and they just have a number sense for how these things are put together. And over time, we can build and lead them to that shortcut. That's not the goal in this early stage, which means I don't have that knowledge in the number line model. I have to do the stand, look, step clearly. All right. That is all there is to the number line model. Of course, it's like a first step to building number sense. So of course, it's not going to be super complicated. The challenge here is to demonstrate and explain things clearly. Are there any questions about the number line model? Any comments? Any observations? Any uncertainties? Anything at all? Assuming, of course, that I didn't spend the last 38 minutes talking to myself and you did actually hear everything I said. I never really know for sure. Maybe there's
Yes, this
okay,
all
good.
seems really
It's gonna happen.
straightforward.
It's gonna happen one day.
Thank you.
There's gonna be a technical issue that I don't realize, and I'll spend 30 minutes talking to myself, and no one says a thing. Hasn't happened yet. It's gonna happen. I'm waiting for that day. No, this is not supposed to be complicated. Actually, the opposite. It's designed to be doable for a grade one student or a kindergartner. Well, maybe not every kindergartner, but it's designed to be simple to get you to the answer. I just want us to be aware because I see every time in the tests, every single time, there's going to be someone that doesn't clearly show their looking and their steps or their standing. Standing is usually pretty good. The looking is where people just, I don't look. Who needs to look? It's a part of this method, and you can't skip it because then it shows you don't really understand how this method works, which means you won't really know how to explain it one day if you happen to sit in front of a student of that level. So it's very important. We're often now with things coming up, we are going back to extreme basics. How do I explain things for the first time? That's a very important thing potentially. All right, that is all I have. Have a look at this. We're going to do the chip model tomorrow so we can take our time. We're not going to be in any rush. So if you have questions or concerns or anything, then bring them up. We can also take the if someone wants to do their oral test when we end the lecture early, we can also take that time. And if you want to do your test, we could do that. If the time blocks don't work for you, I scheduled some blocks, just guessing. First come, first serve. If you want to do your test, don't wait too long because the longer you wait, the more variety in the questions there could be. But it's totally up to you. Don't wait until the end and then everyone scrambles to get their test in. Well, that's not the point. If you have any questions about any of those things as well, let me know. But I'll hang around for the next 9 minutes in case those things are issues for you. Otherwise, I will see you tomorrow.